Today we are going to look at the solving the nonlinear system by Newton's methods. Okay, nonlinear system will consider the simplest nonlinear system. At least it consists of two nonlinear equations. It make up a nonlinear system. And then we assume that the initial approximate solution to nonlinear system 1 is known as xiyi. Mean the solution means that when we plug in x and y in both equation, will satisfy the right hand side, which is equal to 0. And then expressing the fxi plus 1, yi plus 1, and gxi plus 1, yi plus 1 in two variables Taylor series expansion at xiyi give equation 2, which is actually expand the equation 1 using two variable Taylor series, where the xiyi is an initial guess, and then xi plus 1, yi plus 1 is a better roots there. So we get from equation 1, we get the first equation, fxi plus 1, yi plus 1 is equal to fxi yi plus delta x, the first equation, and then you have the multiply with xi plus 1 minus xi, or this one later we denote it as a delta x. They cannot not right. Then plus delta y fxi yi plus 1 minus delta y. This one we denote as a delta yi. So similarly for second equation, mean all the f here replaced by function g. So you notice is actually we actually truncate up to after second derivative we truncate it. So this is a Taylor two variable Taylor series expansion up to first derivative. So we have this is a f is function of x and y. That's why you can do the partial derivative respect to x, you do the partial derivative respect to y. So same with the second functions here. And then since the xi plus 1, yi plus 1 are the better roots, then fxi plus 1, yi plus 1 equal to 0, and gxi plus 1, yi plus 1 will be equal to 0. From okay since the given initial guess mean given xi yi, we will get a better root xi plus 1 yi plus 1, hence fxi plus 1 yi plus 1, this term equal to 0, gxi plus 1 yi plus 1 also equal to 0, and then you bring the term fxi yi to left hand side, gxi yi to left hand side. So we obtain the equation 3, which is here, negative f xi yi. So this negative g xi yi. So you differentiate delta x, the first function. Delta xi, as I said, is a xi plus 1 minus xi, increment of x. So delta yi is a yi plus 1 minus yi. This is so called the what we call the mean the right hand side. Right hand side we can put up into the, this is a J, stand for the Jacobian matrix. Mean the J is actually the Jacobian matrix, where you have a two equation, then the Jacobian will be 2 by 2. If you got three nonlinear system, then the Jacobian will be 3 by 3. And then the first column is actually a differentiate respect to the first independent variable, which is a x. Second column differentiate respect to y, and then first row is actually you differentiate respect to the first nonlinear equation. Second row differentiate respect to the second nonlinear equation. So if you got two nonlinear system, You have a delta xi, delta yi. If it's 3 by 3, let's say you got delta zi. If three nonlinear equation. And then, okay, you see here, mean the negative fxiyi, negative gxiyi, we bring to the right hand side, become negative fxiyi, negative gxiyi. Okay, notice, okay, the right hand side here we can put into the matrix form, Jacobian matrix. Okay, multiply the delta here, Jacobian matrix multiply delta xi, where this is a vector x, okay, consists of delta x, delta y, equal to negative f xi yi. So remember your metric multiplication, 2 by 2 times 2 by 1. Okay, number of column in the first matrix equal to number of row in the second matrix. Then these two matrix can be multiplied. The resultant matrix will be 2 by 1. So this is a 2 by 1 matrix where, okay, remember the metric multiplication, you take row times column, first row times first column, you get here first row, first column, which is del f del x multiplied delta xi here, plus del f del y multiplied delta yi. So first row, first column, then you get the negative f xi yi here. Okay, second row, del g del x multiplied delta xi plus del g del y multiplied delta yi, so equal to negative g xi yi. So in the metric form, this is j delta x equal to negative f. So initially, we have a nonlinear system. After we take the Jacobian matrix, after we take the Taylor series expansion, we get the Jacobian matrix multiply delta xi equal to negative f. Okay, this is a become system of linear equation, or the linear system. And then we can solve for delta xi by taking using the inverse metric method. So a negative follow. So here the delta xi is equal to negative inverse Jacobian multiply vector f. Okay, and then once we obtain the delta xi, our purpose is given xi, you want to get the beta root xi plus 1, yi plus 1. So mean delta xi is known, this is known, then we can get xi plus 1 is actually xi plus delta xi, yi plus 1 is a yi plus delta yi. Okay, this is in the vector form, vector xi plus 1 equal to vector xi plus delta xi. Okay, vector. So in the vector form, expansion form. So vector x consists of the element x and y. So delta vector x consists of delta xi, delta yi. Okay, as I said, okay, this is the simplest nonlinear system. You may have a three nonlinear equations such as f, x, y, z, let's say equal to 0, g, x, y, z equal to 0. Let's say h, x, y, z equal to 0. Then the Jacobian will be 3 by 3 matrix. So first column is your del del x, the first function. Okay, and then second row del g del x, third row del h del x. Okay, second column is del del y f. So this is del g del y, del h del y. Okay, third column is del del z, the first function. Okay, second row del g del z, and then you have del h del z. This is your Jacobian. And then your delta x, you may have here, this is delta x I, delta y I, delta z I. Then equal to negative, okay, your function f g h. Okay, and so on. The technique can be extended up to n non-linear equation. So we repeat back the procedure for solving the nonlinear system using Newton's method. Okay, we show the simplest nonlinear system, fxy equal to 0, gxy equal to 0. Okay, to get the solution by Newton's method, first step, you obtain the Jacobian matrix. This is only two nonlinear equation in terms of variable x and y. Then first column you delta x. Okay, this is differentiate respect to the first nonlinear equation. Differentiate respect to the second nonlinear equation. Second column is differentiate respect to y. So this is differentiate respect to f. This differentiate respect to g. Okay, obtain your vector f is actually, okay, first row is a fx, the first nonlinear equation. Second row is a second nonlinear equation. And then you solve, okay, the linear system Jacobian delta x, okay, equal to negative f for delta x using inverse matrix method. Okay, then xi is a initial guess. Then we obtain the delta xi from step 3. Then we can know the vector xi plus 1. So repeat step 3 and 4 until, okay, the modulus of xi plus 1 minus xi less than epsilon. Okay, if we use a 4 decimal place, epsilon we use 0.005. And then lastly, the root is xi plus 1, the vector xi plus 1. Okay, example, okay, we got two robots are moving on xy plane. Let movement of robot 1 and robot 2 to be described by the function fxy and gxy respectively as x, okay, fxy is x squared plus y squared minus 8x minus 4y plus 11 equal to 0. Gxy equal to x squared plus y squared minus 20x plus 25 equal to 0. Okay, but I'm sorry I didn't indicate which is f, which is g. Then use Newton's method to indicate one of the meeting point of this two robot, which is located in the interval. Okay, the solution for two nonlinear equation is actually their intersection point. So you got one intersection point, another intersection point. The equation 1, the root, which is in the interval 4 to 6. X is in the interval 4 to 6, y 0 to -2. So mean they want the bottom root. They want the bottom root. So initial condition, you may choose, okay, x between 4 and 6, I may choose 5. Y you want to use 0 for easy calculation, or you want to choose, okay, between 0 to -2, you choose -1. So up to you. You may choose, okay, your, okay, x naught, y naught, either 5, 0, or you want 5, -1. Okay, now we are going to solve this thing in Microsoft Excel. So and keep it. So I'm going to, I cannot copy the equation. Okay, and go to the Microsoft Excel. Okay, I got to copy the whole thing. Put it here so that, oh, put it here. Okay, I want to see. Okay, we want to solve this one using the Microsoft Excel. Okay, but okay, hold on. Okay, I have the I maybe put it here. Yeah, I, and then the vector. We got vector x, vector. Okay, sorry, vector x. What is it? Why cannot type? I might start here. Okay, I got I here, vector x, and then the Jacobian. We need two column, so I have the Jacobian. Okay, the vector f, and then I need the delta x. Okay, you can insert symbol. I want the delta. Okay, I don't put the I because need to type the subscript. Okay, Okay, I start with 0. Let's say initial point we choose 5 and maybe 0. Okay, but before that, okay, I need the equations. Okay, we got this non-linear system. So first of all, we need to find the Jacobian matrix. Jacobian matrix. Then I find the del f del x. Differentiate, okay, function f respect to x. So you delta x squared is 2x. Delta x y squared is 0 because when you delta x, y is constant. So delta x negative 8x, you have negative 8. Delta x negative 4y is 0. Delta x 11 is 0. Then you find del f del y. When you differentiate respect to y, x is constant. So delta y x squared will be 0. Delta y squared is 2y. Delta y negative 8x is 0. Delta y negative 4y is negative 4. So delta y constant is 0. Then you find del g del x. Okay, differentiate function g respect to x. So delta x squared you have 2x. Delta x y squared is 0. Delta x negative 20x is negative 20. Then you find del g del y. Okay, delta y x squared is 0. Delta y squared you have 2y. Delta y negative 20x 0. Delta y 75 is 0. Okay, that's why your Jacobian, okay, del f del x is 2x minus 8. Del g del x is 2x minus 20. Okay, del f del y is 2y minus 4. Del g del y is 2y. Okay, and then your function f is actually, function f is your x squared plus, first row x squared plus y squared minus 8x minus 4y plus 11. Second row is a second nonlinear equation, x squared plus y squared minus 20x plus 75. Okay, we call nonlinear equation because, okay, if linear, only x power 1, y power 1, but here you got x squared, y squared. So this become two nonlinear equation. Okay, then become nonlinear system. Okay, we choose 5 and 0 because here, okay, in x between 4 and 6, I pick up 5. Okay, and then y I may choose 0, I may choose negative 1. Doesn't matter. Okay, and then now I'm going to find the Jacobian. Okay, Jacobian matrix. Yeah. So the first cell is 2x minus 8. So to type in formula in Excel, make sure you type in equal, then 2 times. You cannot type x. X is stored in C3. So click C3. Minus 8. Enter. So mean if you calculate manually, 2 times 5, 10 minus 8 is 2. Okay, first row, second column is 2y minus 4. So 2 times, click the location of the y, minus 4. Mean y is 0, so minus 4 you get negative 4. Center it. Second row, first column of Jacobian is 2x minus 20. So 2 times, click location of x is here, minus 20. Okay, center it. Okay, the last k entry is 2y, so equal to 2 times. Okay, this is y. Done. So we completed the Jacobian matrix. Okay, and then we calculate the vector f. Vector f we have here x squared. So click x squared plus, click y squared is a, okay, this symbol okay, shift 6. So minus 8 time is a, okay, shift 8, the star there. X minus 4 times y plus 11. You can check, okay, the formula. X squared plus y squared minus 8x minus 4y plus 11. So one done, enter. Okay, I prefer to center it. Second element of vector f is x squared. So x squared plus y squared minus 20 times x plus 75. Okay. And then we are going to solve the Jacobian matrix. No, sorry, the delta x. We are going to solve the delta x. Okay, delta x. Okay, delta x. Remember, we get the system. What we obtain is the system j delta x equal to f. So delta x, negative f, is negative inverse Jacobian multiplied vector f. And then to do metric multiplication in Excel, okay, in Excel you will have, okay, so equal that, you cannot type, so you equal negative, okay, mmult metric multiplication, okay, metric multiplication of, and then find the inverse. The command is m inverse. Okay, you cannot type j, select the range of j, multiply f, also select the location of the f. The command m inverse, open close, okay, parenthesis, select the range of your Jacobian metric. This is for the j inverse. Okay, metric multiplication is, we have first metric is a j inverse, and then multiply with vector f, negative, because the equations, okay, when we do the Taylor series two variable Taylor series expansion, okay, left hand side is equal to 0. When you bring the fxi yi gxi yi to left hand side, you got negative, come with the negative there. Okay, so now we are going to calculate, okay, we are going to calculate the delta x, okay, vector. So we select the location of vector is equal to negative mmult m inverse. Okay, you see mmult array 1, array 2. Array 1 is a inverse, inverse. So you see m inverse, okay, finding the inverse of a matrix. So you select the inverse location of your j Jacobian. Okay, we are going to multiply inverse Jacobian with vector f. So you see negative mmult, comma, open the parenthesis. For any function in Excel, make sure you open close parenthesis. So m inverse, open close, select the range of your vector j, metric j, comma, okay, this is a vector f. Okay, and then press Ctrl Shift Enter. So we obtain the, okay, solution. The delta x is 0 and negative 1. Then we complete the first iteration. So mean with the initial vector 5, 0, we can obtain the delta x node, which consists of 0 and negative 1. Then when I equal to 1, we can find the vector x number 1 is actually vector x node plus vector delta x node. Okay, if you deal with, okay, more than one cell, please select, okay, that's, okay, location and press Ctrl Shift Enter. So that's what we have. The procedure. Yeah. Okay. Okay, vector xi plus 1. When I is 0, given vector x node, you can find vector x number 1, okay, is equal to x node plus delta x node. Here, deal with vector. Okay, if you don't want to deal with vector, then you deal element by element. Okay, little x1 will be x node plus delta x naught. So can you do one by one? Okay, y1 equal to y naught plus delta y naught, like this. Okay, and then we can copy down all the formula. Okay, and then this is a error of vector x, magnitude of the vector x. Okay, we can have ABS. No need. You can, okay, how to stop? Okay, how to stop? See the okay, to stop. Okay, you can get the absolute value of vector xi plus 1 minus xi less than epsilon. Okay, that's why I'm going to find absolute. Okay, if this one, okay, or you deal with the whole vector, so equal x1, but we have the absolute value. Okay, never mind, we do one by one. Okay, like this. ABS x1 minus ABS is absolute value, x1 minus x naught. I can copy it down. You see, because of the relative row. When you put absolute C5 minus C3, when you copy it down to the next row, it will become C5 will move to C6, C3 move to C4. That's why formula you can copy it down. Okay, that's it. Okay, you iterate until the vector x here less than epsilon. Okay, in this case is 0.005, so this value still greater than the epsilon. Then we proceed to the next iteration. Okay, and then we may, I didn't fix, so here we use up all the calculation. I just show, this is just show the display to 4 decimal place, but the actual calculation is take up all that decimal place that used in Microsoft Excel. Okay, so you can stop here. Sometime you see if we use this one, still greater than epsilon, but if we use here delta x, when the delta x less than epsilon, you stop, the solution will be x number 3. But if we use this criteria, the modulus of vector x3 deduct x2 must be less than epsilon, but this value greater than epsilon, this one still also. Then we iterate one more time. Okay, so you see this one 0. Okay, and then when I stop, because I use the criteria since the modulus of x number 4. Okay, I have to type this x number 4 deduct x number 3, less than epsilon, which is equal to 0.005. Thus the root is x number 4, which is, put it in a vector form, 5.0652, then negative 0.8045. Okay, you may, if you want the upper script, have to format here, superscript. And go to select this one, format cell, superscript. Format cells, click superscript. Mean if you use this criteria, follow here. Repeat step 3 and 4 until modulus of xi plus 1 minus xi less than epsilon here. Okay, if you use the delta x, because delta x is the changes, if you use delta x less than epsilon, then you can stop at I equal to 3. If you use this one, this one means x number 4 deduct x number 3 must be less than epsilon, then you stop at x number 4. X number 4, where the solution is your x is 5.0652, y is negative 0.8045. Okay, so this is using Newton's method. And then you can actually just copy it. If you want to find another root, we got two roots here, right? Where's the question? Let's say I want to find the top root. I just take the initial guess, x is 6, let's say y is 4. I just put 6 and 4. 6 and 4. So also stop. Also stop at number 4. The solution is, I can copy it in this thing. .5348 and then 3.6045. If I use a criteria, modulus of x number 4 deduct x number 3 less than epsilon, then the root is x number 4. Just now I said you may put, let's say, find -1. If you put find -1, I think you can, and then you use a criteria modulus x, you can stop at here, this answer. I mean, if find -1, we get at I equal to 3. That's why different initial guess you may get different number of iteration. Mean if you use find -1, cause find -1 is closer to the root, I think. Find -1 instead of find 0. That's why find 0 you take more, one more iteration. You put find -1, then step number 3 you found the solution. And then if you use the criteria delta x less than epsilon, you stop at iteration 2. So it depends on the initial condition also how far it close to the solution. So 5 is here. Then you see how flexible if you use Excel, you can just change initial condition. You can find the second root. Just change it here. If you use calculator, if you change the initial condition, all the calculation here have to change. And then if you want to find inverse matrix method, you need to go to the matrix mode. Matrix mode. And then when you want to do let's say find the x number 1, y number 1, you need to go out your matrix mode. And then once you want to do the find the delta x, you need to enter back your matrix, define and enter back your matrix, which is more troublesome. So using the Microsoft Excel will be much easier and faster. Maybe for those are interested using calculator, I'll show you. This one. So if you use calculator here, find -1, then you calculate this one normal. If you calculate manually, let's say you key in this one 2x minus 8. Let's say I show you. Find -1 we put in, and then you want the first Jacobian. Let's say you put 2x. 2x. Then you calculate. So x is 5. Sorry. We got 2x minus 8. Then you calculate. So x is 5. So you got answer 2. Second cell here, 2y minus 4. 2 alpha y minus 4. You calculate. So y you plug in -1. So you get -6. The third element of your Jacobian is 2x minus 20. you calculate. So x already 5, go down, and then you just accept, pressing equal, you get -10. Okay, later input this one 2y, 2 y, calculate, so y already -1, you accept, just equal, you obtain -2, and then calculate f and function f and function g. So alpha x squared plus alpha y squared minus 8 alpha x minus 4 alpha y, okay, and then plus 11, you calculate. So x is 5, go down, y is -1, and then equal. So you obtain the first case fxy is 1. Then calculate the function gxy, alpha x squared plus alpha y squared minus 20 alpha x plus 75. You calculate. So x already have input of 5, y is -1, and then equal. Also, you obtain 1. Now you want to do k delta x. So this is we use an inverse k Jacob negative inverse Jacobian multiplied by vector f, right? So we need to in matrix mode. So matrix modes you need normal calculation in the mode calculation. Calculate. Then you need to go to the matrix matrix number 4. So we put Jacobian in the matrix A number 1. So we in this our Jacobian is 2 row, 2 column. So you input a Jacobian 2, -6, -10, -2. Okay, your Jacobian, you put it 2, -6, -10, -2. Then we input vector f. So option, define matrix. Vector f, we put it as matrix B, number 2. Number of row 2, number of column 1. So you put in, okay, first one is 1, second row also 1. Okay, and then we want to do negative inverse Jacobian multiply with f. Okay, where in this case, we represent using calculator is, okay, J represent using matrix A, F represent using matrix B in your calculator. Okay, so your options. So okay, number 1 for you to define matrix. Number 2 is if you have any mistake in your matrix, you can edit matrix here. Number 3 is for metric calculation. So you want to do the metric calculation, we choose number 3. So it's negative. We want inverse Jacobian, which is stored in metric A. So call option metric A is 3. And then inverse, we press the inverse button. Then multiply the multiplication button, metric B, which is store the vector F. So number 4, B, number 4. Now you get 0.0625, 0.1875. Okay. So once you're done, you want to do this one. Okay, unless you have another calculator. You got another calculator. Otherwise, if you want to do in normal calculation, you have to exit the matrix mode. You got to exit your matrix mode. You see, if you exit, mean I want to do this calculation. Oh, I know. Unless I do vector x, I also use input another vector x. Okay, so option, I input vector x as a matrix C. So I define number 3 matrix C, 2 rows, 1 column, 5, -1. Okay, so now I want to use, because now I define this matrix as C. Okay, and this one is stored in, this one missing. This one is in max answer. stored in max answer just now. Okay, this is C. So I'm calling take C and up with max answer. So option, metric calculation, and then option, metric C is number 5, add up with option, okay, metric answer number 1 here. So you get, okay, 0.5625 here, negative 0.8125. I think, okay, this one. Okay, later on, this one, okay, since you deal everything in matrix, so this one, how you calculate this one? The matrix, because if you want to get this value, if you do in your Jacobian, you don't know this value, right? You have to calculate 2x minus 8, but in matrix mode, your matrix there, let's say options, option, I want to edit matrix is number 2. Jacobian we store in matrix A. Okay, unless you use another calculator to calculate and you know this value. Otherwise, okay, you have to, this one is 2, this value is 2 times x. Then x is here, 2 times 5.0625. Sorry, wrong. This value 2x minus 8. 2 times x is now is 5.0625, then minus 8. So you get 2.125. Mean you deal with here. But in matrix, if I don't want to each time, I cannot put it, let's say I want here 2y minus 4. Let's say I want to put 2 alpha y minus 4. Let's see whether I can calculate now. Cannot. Negative 6. I don't know where they take the y there. Cannot. So, okay, 2y minus 4, better you here. 2 times, the y is negative 0.8125. Now you see, wrong mistake here. Okay, 2y minus 4, 2 times. The y is negative 0.8125, and then minus is 4. No, only I get the correct value. Negative 5.625. Okay, and then the here 2x minus 20, 2 times. Okay, x is 5.0625. Okay, 10 point. Oh yeah, forgot to minus 10. So 2 times x is 5.0625. Okay, this cell, minus 20, minus 20. So you get negative 9.875. Okay, the last k value for 2y is 2 times. See the y? Negative 0.8125. So you get here. So you see, okay, how tedious, how tedious you calculate one by one. If you use Excel, once you key in the correct formula, you just copy it down. So now you already update your Jacobian. Okay, you need to update your vector f. Okay, vector f. So you need, okay, correct, the value, the Jacobian. At step 1, your Jacobian is updated. Then you go to edit matrix, edit your vector f, which is stored in matrix B, number 2. Okay, instead of 1, 1, now you need to update this one. You calculate here, or easy, you calculate this one using another calculator. If not, x squared, x is here 5.0625, and then you square it, plus y is negative 0.8125 square it, minus 8 times x 5.0625 minus 4 times the y is negative 0.8125, and then plus 11. Okay, each of it you have to press, and then you may key in, let's say, one digit wrong, then the answer is wrong. Negative, what obtain negative 0.034. Okay, yeah. Okay, slightly different with okay, here's slightly different because we input 4 decimal place, but the calculation in Excel actually here is only display purpose. I display 4, but actually it take up all the decimal place. I think 9 decimal place there. So you edit this one. Again, the x, you see the calculator value because we input 4 decimal place, but in Excel it take up all decimal place. So this is a x squared plus y squared is okay negative 0.8125 squared, and then you minus 20 times x, which is 5.0625. Okay, minus 20x plus 75. So you get, okay, here 0.0390625. Okay, so here updates your A and B. Now again finding your delta x. Delta x, so option metric calculation. So it's negative option metric A, which is stand for Jacobian, number 3, and then inverse multiply vector f is stored in B, number 4. So you get here 2.7877 times 10 to the power negative 3. The answer is slightly different because calculator we have a rounding error to 4. Second one, I change to, I think, number format 3 fixed to 4. See, 0028. Okay, Excel is 0026 because it take out all decimal place. Calculator we round to 4 decimal place. And then you need to take, okay, to calculate x number 2. So options, you take this one plus with make answer, and oh, this one we already. So vector C you have to update. Option edit matrix C. Just now 5 negative 1 now become 5.0625 negative 0.8125. So matrix C is updated. Then you clear. You can take option. Matrix C is number 5 plus options max answer just now. So you get here 5.0653 second negative 0.8054. Okay, calculator and Excel run okay a little bit because okay calculator we update to 4 we key in 4 decimal place. Okay, it tedious to key in all decimal place. I just key in 4 decimal place. So you can see how tedious if you use calculator, you have to calculate one by one. But if you use okay Microsoft Excel, you just make sure you key in the formula, okay, the first formula correct, then okay all here formula correct, you just copy it down. Okay, And then later on I'll show you. You can also this one using the Microsoft Excel solver to uh, obtain the root of the nonlinear system. Okay, what you need to do, you have the f x y. This one you square it. Okay, we take the square. Okay, we try to use a Microsoft Excel solver. Okay, Excel solver. Okay, what I'm going to do is this is x, this is y, and this is your f x y. Yeah. Okay, and this is g x y, and then you have sum of squared. Okay, x, let's say we take 5 0. Okay, fxy. Okay, that's fxy here, equal to the x squared plus y squared minus 8 times x minus 4 times. Okay, sometimes the cell is blocked, so y is C33 plus 11. See, okay, we use the same here. So find -1, get 1. Gxy is the x squared plus, this is the y squared, and then minus 20 times x plus 25. Okay, sum of squared mean exactly it takes fxy squared plus gxy squared. And then we'll minimize this sum of squared equal to 0 using the Excel solver. Okay, if you cannot find this solver, then you go to far more options, add in, and then go here. Make sure you check on this solver add in. So once you click OK, you can see the solver here. So you click the solver. Okay, mine is a new layout. You may have a different layout, like in the where's the books? The books like this. Okay, this is the old layout. Okay, mine is a new layout. Set objective. Okay, objective. Okay, we want this square sum of square equal to 0. So I want to minimize it to the value of 0. Then I want this cell. Okay, I cannot click. Then I type in dollar. This cell is F33. F dollar front and back mean fixed at that cell 33. I want to set the sum of squared cell equal to 0. Variable to put. Okay, I want the cell x and y to be varied so that sum of squared here become 0. I want to add. Can I vary these two? Okay, so you see, sometimes I can click. So $B, $33 up to $C, $33. Mean varied the value of x and y to, okay, varied x and y value so that sum of squared equal to 0. Okay. Okay, and then I want to solve this one. Click the right arrow. So they are solving. So you see, initially I put 5 -1. So it takes some time to solve. Model Q to be solved. Okay, solver add in, solver found a solution, all constraint and okay. So you see the solution that given is here 5. Why not optimum? Okay, hold on. Let me check. Why not that? Okay, we check back. Why just now? Objective minimize the F33 by variable B33 to C33. And then I solve it. They obtain this value. Let's see. Let's say if I put another root 64, then ask it to solve again. Okay, we put 64, we obtain a 4 decimal place. Same. Okay, same with here, but just now, why we put 50, we cannot get it. 5 negative 1. Okay, we put the second root, the third root, we get it using solver. Let's say try put 50, 50. Solve. Because I put 5 negative 1, y is obtained as 0, which is quite far away. I mean, not accurate. I don't know what happened. The first root is not accurate. Suppose it's can one. Okay, but 64 correct. Okay, 64 correct. The first root not accurate. Only 64. Okay, the top root we can obtain it correctly, but the second one we keep on getting 5 and 0. No matter I put 5 negative 1. Check whether the equation correct. X squared plus y squared minus 8x minus 4y plus 11. This is a x squared plus y squared minus 20x plus 11, correct? Minimize F33 by vary B33 and C33. Standard nonlinear. Okay, they got the algorithm. It got 3 different engine. Let's try this one. because this is not linear, that's why you cannot choose a linear programming LP. So find -1 here. Because just now the first K engine it cannot obtain the correct answer. So I try to change to the second engine there, which is the second algorithm. Also not correct. Oh, this one, not all solver have upper and lower bound. Okay, solver. Evolution cannot. Non-linear. Automatically. Okay, or we choose here automatically select engine. Solve it. Solver found a solution, but the solution here not accurate compared to here. So this one I cannot figure out. Why? Because last time when I use the old one, should be able to obtain the same solution. But now using this new layout, I can only obtain this root only. The bottom root cannot. Okay, so you can check it out using your Excel. Okay, with this, thank you.